Okay, hello once again, and now I believe we are ready to start. Thank you everyone for accepting my invitation and joining today's workshop. I'm Katie Jovanovska, Marketing Program Manager at Kumo, and I will be your host today. In this workshop, we have Randy Pettus, Senior Partner Solution Engineer at Snowflake, and Akhil Ramasagaram, ML Solutions Architect at Kumo. Today, they will speak about how to train and to deploy predictive AI models directly inside Snowflake using Kumo. Before we begin, I would like to invite everyone to use the Q&A section to ask any question throughout this session. At the end, we will dedicate around 20 to 30 minutes to answer the most relevant question, and for the one that we don't have time to answer live, we will follow up through email. And now I would like to invite Randy from Snowflake to begin this workshop. Randy, over to you.
Thank you, Katie. And welcome, everyone. My name is Randy Pettus, and I'm a Senior Partner Solution Engineer at Snowflake, where I have the pleasure of working with incredible partners like Kumo. So prior to joining Snowflake, I was actually a practitioner in the data science space. So I know firsthand many of the challenges we face in data science and machine learning and AI. And so that's why I'm excited to be able to share more about how you can build smarter and faster solutions with Snowflake and Kumo. And so keep in mind, we're going to have an awesome demo of what this looks like. So please be sure to stick around. So let's set the stage for the demo and what we'll talk about. And really, everyone's talking about AI today, but for those building these solutions, getting to production is still, very painfully hard. First you have workflows that are fragmented. You have different tools for prep, for training, for deployment. You have multiple environments. It creates this fragile and inefficient and hard to govern space. You often have data that's getting duplicated, going outside of your governance boundary. And again, you end up with this just very, very fragile state. In addition to that, there's the data, the modeling side where you have dozens of tables across formats. You have different data types with structured and semi-structured, unstructured text like reviews or feedback that you're getting from customers or logs. And really that makes modeling messy and time consuming. And so the data scientists, end up spending a ton of their time just feature engineering. And so even after you've gone through these challenges and say you've built something great, it often gets hard to share. So you get models that are either stuck in notebooks or stakeholders wait often a lot of weeks or months to even see results. And so if they ever even do see the results, it's taken all of this time, or you end up in just this pilot purgatory phase. And so these just aren't technical hiccups. These are real blockers to business values. And so with some of those roadblocks in mind, let's look at just a better path forward. And this is really one where your data, your tools, your people are fully connected. And so with Kumo and Snowflake, as we'll show, you're no longer just stitching tools together. All this can be done in one cloud platform where your data, your notebooks, LLMs, GPUs, apps, all of that's happening in one place. And so you can really go from exploration to deployment without ever having to leave this single environment. And this is also going to enable modeling across structured and unstructured data, across all those different tables that we were talking about in the previous challenges. And you're not going to have to build extra pipelines to do so. Kumo is going to take this further with its approach to be able to leverage, deep learning for relational AI, or relational data, I should say, outperforming traditional methods while cutting down, all that model development time that we're talking about, all that feature engineering that can really consume your time as a data scientist. And so even, again, when it's time to collaborate, we'll show you how you can just very easily share notebooks, models, apps directly without even having to move that data around. And all of this is going to be secure and governed. So it's all about removing that friction. And we'll see how you can even leverage LLMs as part of this process to really drive this home and to make you more efficient, all again within this single environment. So that, just want to talk a little bit about the Snowflake aspect of this. As I mentioned, all this can be done in a single cloud platform. And so with Snowflake, you really have this one environment that's going to bring across all these pillars that you see here. This includes analytics, AI, which we're going to hone in on a lot more, the data engineering side of things for all those transformations, the pipelines, And then also on the apps and collaboration side, where you can easily share your models, your data, your apps, both inside your organization, but also externally, or even be able to take advantage of other data sets and apps through our marketplace. And all of this is on this fully managed service. So you're not going to have to waste your time managing infrastructure. And it's cross-cloud and built with security, of course, first in mind. So from just moving on a little bit to some of our AI and ML features, Snowflake has really moved beyond just analytics. And so, as I mentioned, it's not just powering the analytics, it's really going to address your enterprise AI and ML challenges. As part of this, we have various features. Cortex AI, it's going to provide you end-to-end capabilities for developing and deploying Gen AI applications. And in addition to ML and AI infrastructure, we also have Studio, Notebooks, Streamlit for really developing and sharing apps. And you'll see a good glimpse of what that looks like today. And really across all of our AI and ML capabilities, you're going to see three key value propositions. And that is, we're going to make AI really easy to use, it's going to be efficient, and trust it. And the great thing here too is with all of this environment in place, we can leverage something like Kumo to just make your life that much easier, again, as someone practicing in the data space. So let's hone in just a little bit more on the Gen AI side, which you'll see some of these capabilities today. But if you look at this slide here, we have really a set of top tier LLM and foundation models, including, again, some of the top model providers, OpenAI, Anthropic, DeepSeek. A lot of those top tier models, you're going to have that exposure directly in your Snowflake environment. And so instead of you having to send that data somewhere else, you get to bring that AI capability to where your data is already secure and governed. And in addition to this, we won't drill into a lot of these capabilities today on like what we have here in the data agents, Cortex Analyst, Cortex Search, but there's also amazing capabilities to be able to talk with both your structured and your unstructured data. So finally, the last piece I'll touch on here is on the native app side of things, and this is really where you can bring in amazing applications like Kumo, again, directly to your data. So what is a native app? You can really think of this as being able to just find an application on our Snowflake marketplace. You can try, purchase, install that application directly in Snowflake. And from there, the app's going to sit securely within your Snowflake account next to your data. So this really allows you to skip those long procurement security cycles. And all of this happens, again, where that data is already secured. And yet you get this amazing application of Kumo in this example. So let's see what that looks like. So this is just kind of a big picture architecture of what it looks like to bring in Kumo to really interact with your data all within that Snowflake boundary. So you can see here, if we're getting Kumo from the Snowflake marketplace, that's going to then sit in our Snowflake boundary, where then it has access, again, with all the RBAC principles that we have in place to provide the right necessarily privileges to that data. You can then take advantage of all that structured, semi-structured, and unstructured data that's coming through, leveraging our Snowflake Cortex capabilities, for instance, using notebooks to orchestrate all of this, explore your data, and then again, do all of that awesome modeling that we'll see with Kumo today. Again, all of this can happen in Snowflake to power those apps, dashboards, and APIs. So this kind of shows the big picture, but I'd love to turn it over to Akhil here, who will show the awesome demo of what it looks like to actually put this in practice.
Perfect. Let me take the screen. Awesome. Hi, everyone. My name is Akhil. I'm an applied ML engineer here at Kumo, and thanks so much for tuning into this session. I hope you will walk away with something really important that you're gonna try and test out tomorrow. If you were like me as a data scientist, if you dealt with messy notebooks, fragile pipeline, or long handoffs, just to get a model into production, you are definitely not alone. I have been through all of that. today I want to show you a different approach, one that is fast, scalable, and built to simplify the move from prototype to production. Let me show you what I've been working on. I've built this quick demo where I built a recommendation system that ranks in the top 1% on the leaderboard, and I wrapped it in a quick streamline app. It's performant, it's clean, and production ready. So what makes it really worthwhile is it's a complex problem to solve, one that requires handling sparse data, shifting user behaviors, and personalized recommendations at scale. Underneath the hood, it's built using the Context GNN framework, which is a state-of-the-art paper that was published last year. Normally, putting together a solution like this, going from model development to deployment, could take weeks, if not months, in a complex environments. This version came together in under 30 minutes. Let me show you how. So we go into our Snowflake notebook. We have three key tables here: articles, customers, transactions. Think of articles as a product tables, which have some structured and some unstructured information as free text. And to me here, the detailed description is one of the key important informations that I wanted to leverage, but in a traditional way of doing ML, I cannot directly incorporate text. If I wanted to, I have to do extensive feature engineering and the additional pipelining on top of that I have to now manage. In another word, I don't have to. There is a better way. The nice part about Snowflake is you can directly bring in the Cortex text embeddings, and you can easily create those. And let's see what that looks like, for example, here. So now I have the embeddings, which I can use for downstream modelings. This is where we bring in the Kumo. With Kumo's SDK, you bring the platform directly inside your notebook where you are doing a bulk of your work already. You don't have to juggle between multiple platforms, having more friction in between. And the flow looks something like this. You simply set up a connector to a database where your tables resides, the one you want to use to solve a predictive task, and then ingest them. Next, you quickly build a graph and establish the connections between the tables in that graph. By what I mean is defining what are primary keys, what are foreign keys, and establishing those links. Once you define that graph, we then solve our predictive objectives in a form of this way. This is a very SQL style, easily understandable to your citizen data scientist, expert machine learning engineer, and most importantly, even your stakeholders. So let's unpack what's happening here. Here, we are building a recommendation model which predicts top 25 items a customer is likely to buy over a course of 30 days. That's all. That's all it is doing in this just 2 lines. In another world, if you have to build this model from scratch, you would have to have thousands of lines of notebooks managing the whole end-to-end doing feature engineering. Now, once you define your predictive task, you can simply kick off a training job with just a few lines of code. And here I just created additional tags just to easily surface the models that we are building. So let's go ahead and see what this model looks like in our UI. This is the same recommendation model that we have built. So if we go into the graph snapshot, we can see the overall graph structure of the problem that we are solving. What tables are we using? What links did we establish? And underneath it, we can also see the graph link health stats as well. So this way, you can quickly identify if you have data discrepancies in your problems that you want to first take care before even looking into a modelings. So if any link looks abnormally low, like 6% or 8% match rate, then you are dropping a lot of information between these tables. You can also see for individual columns how bad the missing values problem is. And then once you are okay with the graph, you can see the training table, like how under the hood Kumo generates the training table as well. Here we can see what prediction window was used for training, what prediction window was used for validation and holdout as well. How many samples were there in each of these splits. And if it is a binary problem, you can also see what is the label distribution across these different splits as well. And coming to the training part, here we see the AutoML hyperparameters for the best model that gave us the good performance. You can also see the individual training metrics, how were the loss functions across different metrics. And if we go back to the evaluation tab, you can also see what is the end model performance on the holdout data set. So you get a really 360 picture of what is your underlying data structures looking like, what is your graph structures looking like, what are the label structures looking like, and how good a model is. But underneath the hood, something really powerful is driving this model. So let's go deep into that. This is where context GNNs come in, the core deep learning architecture that's powering everything that you just saw here. Context GNN is a specialized graph neural networks designed for recommendations tasks. It's built to model user behaviors over time by capturing relationships between entities such as users, products, visits, actions as a temporal graph. Unlike traditional models that rely on static features or tabular data, Context GNN uses the structure and timing of real-world interactions to learn rich embeddings without you needing to manually hand engineer features or flatten complex tables from relational tables. So while the Kumo SDK makes it really simple, you are getting the state-of-the-art, purpose-built deep learning architecture that's been proven to perform, especially in sparse or evolving data sets in recommendations tasks. Now, once you have a model in production now, let's see how we can start generating inferences. You can simply plug in this piece of code to your favorite orchestration tool and not just generate predictions, but also generate embeddings for downstream pipelines if you want to do real-time serving as well. So here I'm generating a predictions for each customer. I want to know 10 articles or 10 products that a customer is more likely to buy. So as you see here, we have our predictions in a table called demo.predictions. So let's see what that table looks like. This is the raw output from Kumo. So think of entities as like customer IDs, class is product IDs that we are recommending, and score is the individual prediction confidence that we have that this is more likely that a customer might buy it. Now, let's say you have a stakeholder who wants to do some qualitative analysis. He wants to evaluate this before running it into a production live. How can you easily go and build something which solves this task? With Snowflake Copilot, you have a really state-of-the-art advanced AI assistants at your fingertips. So gone are the days where you have to build something from the scratch. I just simply have to tell the LLM what is my overarching goal, some context around the tables that you have, the outputs that you are looking, what is the task that you're wanting to perform. And it does a pretty damn good job at giving you a skeleton code. And all you gotta do is just simply take this, plug it into your app, and voila, it does the job. All I had to do in this case was just make sure that the tables are pointed in the right location, make sure that it's using the right column names. And the best part is this app isn't just for you. You can now share this app to any other stakeholders inside your organization, or you can even have additional user administration permissions on top of this to make sure who can access and who cannot access this. So the key message I want to emphasize here is you have seen how we could build models, train, and deploy them directly inside the Snowflake. we have seen how we can seamlessly embed free text into your models. With GNNs, we can capture complex relationships without doing any manual feature engineering, any flat table creation. And by simply letting GenAI handle the wiring, you as a data scientist can focus on the logic part. So on a closing note, what you just seen here today here, this isn't a shortcut. This is the new normal. This is what doing data science in 2025 looks like. So if you enjoyed today's presentation, we encourage you to try out our free trial on the Snowflake. We have plenty of example notebooks available for public, so you can see what kind of use cases that we've solved using GNN. And if you'd like to get in touch with us, you can reach us at here. Yeah, with that, I will hand off to Katie now. Katie, I think you're on mute.
Okay, great. Thank you so much for your sharing your knowledge, Randy and Akhil. Now we're starting our Q&A section. We've received many interesting questions. Akhil and Randy, probably you are able to see them in our channel. Or maybe I can start with reading the first question that we received. So probably the first question is for Randy. Randy, how does Snowflake manage data governance when integrating Gen AI workflows into the platform? Are you able to answer this question? And you're also muted.
Yes, I am also muted. Yeah, no, I mean, the great thing here from a data governance perspective is, we have brought these models, whether that's open AI models coming, or if that's Llama or Anthropic models, all of those are within the boundary again of Snowflake. And so in terms of a governance perspective, often you have AI security reviews, all that kind of stuff that you have to do from a company perspective. But again, the great thing that simplifies all those conversations and all of that process is all of that LLM capability is again brought into your governed perimeter here. And so instead of, again, you having to take like external calls of, you take your data and you have to hit some kind of external service, that is eliminated here. And again, all of that AI capability is brought to, again, where your data is.
Thank you so much, Randy. The second question is the following. What level of interpretability or explainability does Kumo offer for the model it builds, especially in regulated industries?
Yeah, so right within the Kumo platform itself, for classifications and regression tasks out of the box, we provide both graph level under explainability, like on a 30,000 feet, what are the gears and levers for a particular predictive task, but also on an individual entity level, what data points are influencing towards the problem. On our roadmap, we are also working hard to bring that explainability for recommendation use cases, for forecasting use cases as well. But currently, out of the box, we support classification and regression.
Thank you, Akhil. The next question is, can Snowflake Copilot be customized or fine-tuned for specific organizational workflows or data contexts? Randy?
Within Copilot today, it will have access to, like in terms of like your actual data, how that works. I don't think you would have the ability to call it necessarily fine-tune Copilot. However, we do have our fine-tuning capability, which does make it extremely easy to fine-tune models. And I can provide links to that process, but we basically have a managed service to make it extremely easy to fine tuning, which could be used in any kind of downstream task. Like a perfect example of that would be like, say you have some kind of classification task where you're wanting to use like an LLM to perform that classification on a bunch of text data. That's where like a fine tuning use case could come in. You leverage the fine tuning capability, and then you could actually do the initial the initial fine-tuning process on like a larger model, but then basically you end up fine-tuning it and leverage a smaller model to make those predictions or the actual like classification from a production standpoint. And so you can basically save on save on costs while still getting, really great performance. And so that capability is there to leverage for the LLMs, but that's a little bit different than the actual co-pilot experience itself.
Great, thank you. The next question that we received is from Francisco. He's asking, is it possible to create a model for multi-horizon prediction in demand forecasting? Additionally, can probabilistic forecasting be integrated into this model? Who can take this?
Yeah, I can take this question. Yeah, I think we launched forecasting GA early this year, and we are solving wide varieties of use cases. I think the key information here is, as long as there are signals in a table and we can establish a graph by establishing links between these tables, and this is a supervised learning. So as long as the labels are also present, we can solve this problem.
Great. The next question from Michael, how do you measure the quality of the recommendations?
I can take this question as well. Yeah, so especially evaluating recommendations quality is a hard task. It is a combination of different things that you do. You can start with the offline evaluations by working on your whole lot. You already know the ground truths that you're predicting and your ranked analysis. So you can do something like a MAP ranking analysis, and then take this offline metrics into the online by doing some sort of A/B testing with a version of models and seeing which one gives you a good lift.
Thank you. The next question from Hadith. Did you design the prediction queries yourself, or are they sampled in SQL Server or?
Yeah, I can take that as well. So these predictive queries are very unique to the individual business problems that we are solving. It's very dependent on the schema, but defining that or coming up with that is actually not that challenging. As long as you have a clear business problem that can be solved and measured, where you know what are the entities at which you are making predictions and what is the clear predictive objective, you can easily define that. On our documentation, we have so many resources which will help you come up with predictive queries for recommendations, forecasting, churn modeling, lead scoring across multiple predictive tasks. So I would highly advise checking the documentation page.
Thank you. Randy, I believe this question is for you. Is Snowflake going to provide Elasticsearch capability on text pattern matching through cosine proximate?
Yeah, so right now and we can provide some documentation on this, but right now within Snowflake, we do have vector data types. And so that will allow you to leverage various text embedding models. And for that purpose, you have the ability to, for instance, from like a RAG application perspective, or really any kind of text matching, you can perform like we have out of the box solution for cosine similarity on those vectors, L2 distance, and so all that capability is built in there from a vector similarity perspective. So that will power your RAG applications if you're building that out by let's call it by hand. You can leverage that directly. We also have our Cortex search product as well, which makes it super easy to not only basically you can think of it as like a managed service for RAG applications, and also like to facilitate search applications. And so with Cortex search, it's not only going to do just like that basic RAG capability, it's also going to be able to do things like re-ranking and more sophisticated methods to actually improve what you would get out of the box, which is like a vanilla RAG type approach. So that's all available with our Cortex search product.
Thank you. The next question. Is there a recommended approach for securely using external Gen AI tools like ChatGPT alongside Snowflake native tools? Randy, I assume this is for you.
For securely using, so the thing I would address with ChatGPT specifically is, so we did just recently announce basically that we're bringing in OpenAI model capabilities directly within Snowflake. That's today within Azure environments. However, we do have cross region inference capability. And so what that means is, say you are in an AWS cloud environment, and yet you want to be able to take advantage of like an OpenAI model, that cross-region inference capability makes it very simple. You basically just turn that on for your account, and that'll allow you to be able to basically go cross cloud to make that happen. And so that's the way that you can leverage, in this case, OpenAI models directly within Snowflake. So again, I think that's the power of what Snowflake has done here from a Gen AI perspective, where again, like we're providing a vast array of these models, state-of-the-art models, all these top-tier models, Anthropic, Claude 3.5, which is the example we saw today. But again, like OpenAI models, all that is directly within Snowflake. So there is the ability, to be able to use. You could set up external access, to make an external call to something like a chat or OpenAI API. That can be done. But again, I think that's where you lose that ability from a governance perspective once that data is traversing outside of your boundary there.
Thank you so much, Randy. The next question: how does Kumo handle data drift or changes in relational schema over time when maintaining deployed ML models? Akhil?
Yeah, I can take that question. So once you have a Kumo model in production and you are running inferences, let's say daily or weekly cadence, you can actually have drift monitoring on your side, and you can constantly check to see how good the model performance is looking as you collect the ground truth. And simply having an orchestration, setting something like, once your model drifts beyond a certain threshold, you can easily kick off a retraining job using the SDK code that I have showed. It will retrain the model with the latest data since then.
Great. Can Kumo models be exported or operationalized outside Snowflake for edge deployments or app integrations?
So yes, right now we only have capabilities to do batch predictions. Real time is something that we are working actively on our roadmap. But from looking at my personal experience, we can solve like 95% of use cases with batch predictions. So with the onset of embeddings, you can export these embeddings and use for downstream pipelines, which could be framed in a real-time settings. So that is like one alternative we have right now, is just take the embeddings as predictions and use them for real-time serving. But Kumo out of the box, currently we do not have a real-time serving product.
Great, thank you. The next question is from Garcia. How does Kumo leverage user context, time, place, assets, liabilities, and item relationship customer who have bought something at the same time?
Yeah, this is a great question. This is a very complex problem. This involves multiple tables. This involves multiple kinds of data points. In a traditional way, you would have to traverse through these individual tables, figure out what is the meaningful way of describing this in your future engineering. But at the end of the day, it's all about a guesswork of, is this the right way of representing this feature or not? But in Kumo way of doing this, leveraging with GNN, we are establishing relationships which are already present in your data. So we do not have to manually create anything, as long as all the information that you just described, all the relationships, all the key points are in your table, and you can have primary key and foreign key relationships established. We can learn all these complex nuances without doing feature engineering.
Amazing, thank you. The next question: what are the cost implications of running end-to-end ML apps directly in Snowflake compared to traditional cloud ML pipelines?
Yeah, I can take that. So in general, things are going to be very cost competitive, especially from like an overall TCO perspective. And so, I think like, for instance, before I joined Snowflake, I was specifically working on a lot of like RAG type applications where you're spending significant amounts of development time on top of those applications. So it's not just the cost of, making a call to OpenAI, or not just the cost of, like that actual LLM call, we'll call it itself. It's not just that, it's the big picture of, well, like how much are you spending on the infrastructure to make that happen? And so again, that's really from like if you especially take that TCO perspective for total cost of ownership view, that's where Snowflake is going to just remove so much of that complexity, the infrastructure necessary to get to your end result. And so, but you'll also see just the overall from like a cost perspective of making those LLM calls, it's going to be very cost competitive.
Thank you, Randy. Next question. What are the performance benchmarks for Kumo's models compared to traditional ML approaches in Snowflake?
Yeah, I can take that question. That's a great one. We already have a rel bench out there for public to see how the relational deep learning does better significantly compared to other tree-based learning models. Doing the Kumo way improves your model turnaround by up to 20 times. The absence of not doing any manual feature engineering, and with GNN's performant model learnings, you can deliver state-of-the-art advanced models in a much faster turnaround time. So what it means is data science teams can solve their problems confidently that they will go through success in a much shorter turnaround time. The time it takes from business problem to predictions available, if it is long, by the time your predictions are available, the business problem is not relevant anymore. So we want to cut this down shorter so that the problems that the data science are working are relevant when they go in production as well.
Thank you. Next question. Can Kumo handle real-time data ingestion and prediction within Snowflakes?
So right now, if it is around the inferences, as I mentioned, we are actively working to get it out there in the GA, but currently we do not have real-time inferences. But if that's a question around retraining, we see customers retraining models on a daily cadence as well, so we can take care of that as well.
And maybe just to add on that from the Snowflake perspective as well, I think it's always important to understand like what is real time, because it's often a relative term until you start really digging into it. But also just like from a, is it a matter of real time for the predictions or the inferencing capability, or is it a matter of the model, like the training process, like the data coming in? So it's like, it's always important just to understand like architecturally, like what is the real business need, and because everybody often refers to real time. And so yes, sometimes that's from the real time on the inferencing capability, but in reality, a lot of times real time is less real time than what the business often initially states.
Thank you. We have two more questions. How does Kumo leverage Snowflake's Cortex capabilities to enhance its predictive AI models?
So I can answer this question. Underneath the hood, we are leveraging the GNN architecture to help solve multiple predictive tasks. Now, to solve these predictive tasks, if you need any Gen AI support, you can rely on the Snowflake's Cortex capabilities and bring those. And by that, what I mean is you can bring structured data like categorical, numericals, even unstructured data like embeddings generated from the upstream Snowflake's Cortex pipelines into these Kumo.
Thank you. How does Kumo differentiate itself from traditional AutoML tools in terms of flexibility and control for experienced ML teams?
Yeah, I can take that question. So it's a two-part question. Let me break that down. In terms of flexibility, like how do we differentiate ourselves? The architecture that Kumo is built on, like the context GNN, with the Kumo SDK, we give freedom and function flexibility for both citizen data scientists as well as expert data scientists to bring the model planner right into their notebook, tweak the architecture to like better suit their needs. So it's not just the two lines of predictive query that I've showed. Like that's not the only thing that you can edit. You can change how you generate the training table. You can change the model architecture in a way that is best served for your businesses. And in terms of other traditional tools and why Kumo, other traditional tools, no matter like which one you pick, at the end of a day, you still have to do lots of feature engineering. You have to manually create training set generation, label generation, which is quite error prone sometimes, where if you inadvertently like incorporate information which is not available at the time you're making prediction, this is how data science projects fail. With Kumo, this is something a data scientist wouldn't have to do. So Kumo automatically takes care of the training generation plan, model generation plan. So rest assured, whatever the training table it generates, it only incorporates the data that is available at the prediction windows that we are solving.
Thank you. So we are receiving, we received two more questions. Thank you for your time. I have one question. In a setup where interface results from Kumo are served via gRPC or RESTful APIs through Snowflake for a recommendations service, what strategy are in place to manage latency and performance impact during real-time API calls?
Yes, I think if this question is around the real-time inferences, right now we do not have a real-time capable inferences out of the box. But if it is latency concern, even during batch predictions, we have customers who generate batch predictions every few hours. We've worked with the customers' infra team or their development team to see what is the workload here to better understand what kind of graph sizes we are dealing with, what kind of prediction inferences numbers that we are expecting. And based on better understanding that needs, we can help them how to better set up the infrastructure needed for Kumo to generate these inferences with much low latency.
Thank you. And our last question is, how does Kumo ensure data privacy and compliance when using external LLMs or services?
Yeah, I can take that question. The neat part about what you just saw here is your data is already residing in Snowflake. The Cortex capabilities or the Gen AI capabilities that we discussed, not just the Copilot, but also the text embeddings, that is already inbuilt, governed, incorporated inside your Snowflake assets. So we are simply bringing Kumo, Gen AI capabilities, and your data just together in the Snowflake to solve problems with the graph neural networks here.
And then again, also from just an application perspective, Kumo, the app in this case, when using the native app within Snowflake is also within that governed boundary as well. So it's basically everything is again operating within Snowflake there from a compliance perspective.
Okay, great. We received one more question. I believe we have time to answer this question. So Akhil mentioned the elimination of the need for feature engineering. How was missing data handled in the demo?
Yeah, this is a common problem that data scientists see across their field. There is different ways to deal, especially with missing values. Anything abnormal, you simply cannot ignore it and go into your next modeling phases. You have to go back to your data sources to figure out how real is this problem, what is the context of this. So inside Kumo, we automatically treat missing values as a separate class at the time of training models or inferencing them. But as I mentioned in the graph health stats, before even taking a model to a prediction, you first want to evaluate, is this model accurate to my understanding? So you can see in those graph health stats are all the linkage what I expect to see in my tables. If you see anything which is abnormal, you then go back to your data sources to see what was going wrong. Maybe I established a link, the wrong primary key or wrong foreign key, and you simply go back, change that, and then re-ingest the graph to see would that solve. But if it's the actual underlying source itself, that's a different question altogether.
Thank you, Akhil, and thank you, Randy. We've reached the end of our workshop. Thank you all for joining, and thank you for your amazing question. I hope you gain valuable insight. Tomorrow, we will send you an email with the video recording, example notebooks, and free trial links. If you have any question, you already have my email, and please reach out to me, and I will connect you with our team. Thank you once again, and have a great day.
Thanks, everyone.
Yep, thank you.